Hello, everyone. I'm
Hello.
Saar.
I'm Ben,
And we're... No.
and it might not be live.
Yeah. Let's see. We're doing our usual thing of trying to figure out if we are live. Yep.
Yep, we're live.
There's something. Something. Ah, maybe later. Oh, okay. Yeah, we're live. Okay. Right. So we're looking at Variety Show channel on our Slack and this other channel. Oh, all good. Yeah, we got it. Good. Thank you.
Thank you.
Right. So we're going to talk today about the next project we will be shipping in 2 weeks, called Lite2Sound BC. The BC standing for Boldport Club, and it's another one of those wonderful collaboration projects with a chap in Texas that runs a company called Rare Waves.
Yeah, it's like a sound synthesizer company.
Right. And it's been a very nice collaboration. We never met the guy, and we never talked to him, but you've known about his work before, and you thought that something might work.
Yeah, I saw his work years ago when he was doing clones of drum machines. Like oh no, I'm on the spot. What's the Roland drum machine? 808 drum machine?
I have no idea.
909s? Yeah.
I have no idea.
Okay. And he did a really good video about analog synthesis making a bouncing ball. That was really good.
Okay. Can we can link to that?
Yeah, I can link to it. Yeah.
We'll link to it in the description. And so you've seen this project and you thought, and we're always on the lookout of collaborating with people, and it's kind of one of the things that at least I enjoy, because it brings in expertise and interesting things from one side, and then we throw in our kind of creativity into the mix to create something new.
And I wanted to do something with analog, electronic audio, basically, and it fitted quite well, this project.
Audio is your thing, right?
Yeah,
one of your things.
One of my things.
Stickers.
My first thing that I learnt.
Stickers is another.
Stickers, yeah.
Yellow things is another.
Yeah.
Right. Okay. Yeah. So so it's all been very smooth, and this is a project that you designed and motivated and so on.
I designed it physically. It was actually Eric's.
Right.
At Rare Waves. His design. It's fully his circuit that he invented.
Yeah, right. So the way, I kind of started doing collaboration, and the way I sort of phrase it to people is to say that I identify a nice project, I contact the people, the person who's done it, and I say, well, you've done all the work, I'd like to re-implement it. I'd like to re-implement it as a Boldport Club project. You don't have to be involved more than you want to. You've already done the work as part of this thing. I just want your blessing for doing this, and
but we sort of take it and we take an idea and make it highly designed.
Yeah. So I sort of think about it as a sort of reimagination of that project.
Yeah. But where you wouldn't typically be using like a... because normally you just make a circuit board and it hides in a box. Yeah. Whereas we're taking a design and we remake it to...
Yeah. So insert the visual elements, maybe even take a different... take the circuit and apply a slightly different concept to it. And then they're free to be involved as much as they wanted to. And of course, we're celebrating this collaboration. We're not hiding the fact that we're taking somebody else's project, but it's very important to have their approval. But in this case, Eric wanted to be involved with the circuit, and he, according with your feedback, he adjusted the circuit. And one of the things that happens in these kind of collaborations is that we have to fit it to our constraints. Like the BOM, minimizing BOM line items, because that comes into play when we're assembling the kits.
Making it easy to build too. Well, I don't mean easy, but I mean like
there's not too challenging.
A large audience, sort of.
There's that back and forth saying, well, we can't quite afford to put this component in the kit. Can we, or this component will require too many peripheral components. So, what can we do? And Eric really worked with us to get that done based on his experience doing these sort of things, which is great because then he's already done it. He knows the domain well. So that's pretty good. We can talk about what we compromised on a bit later from his original design,
and also sort of challenges we've met as well. Things like the capacitor issue. Everyone knows about these days. Yeah.
Well, I'm sure some people get caught by surprise.
Yeah.
I mean, we would if we didn't. I think when Mike Harrison was here, he mentioned it.
Yeah, he talked about it. Yeah.
And
apparently the resistor one's coming.
Really?
Yeah.
Oh dear.
According to Hackaday.
I imagine a lot of people are just stocking up now.
Yeah.
That doesn't help, right?
No.
There's going to be like secondary sellers. People have stocked up on things, and it's going to be a mess. But this is only surface mount.
Yeah.
Okay, so let's start showing the stuff. Actually, showing what it is.
Yeah.
We didn't even show anything yet.
No.
All right, so I'm gonna transition.
This is a display.
Ben set up all the stickers. Yeah, we talked about that.
This is the board. Shall I show the kit?
Just do a kind of mini unboxing, unbagging.
So this is the kind of packaging it's going to come in. And so for this project, quite unusually, the idea is to make the packaging as part of make it the enclosure, because it works quite well for audio stuff, audio design.
Yeah, I think it works here very well, particularly because it's a tin. And but when in previous projects, it's always nice to have the packaging be something useful for the kit, ideally. But maybe even as a storage, where you can store the kit that you've built and things. So we definitely think about it. Like a project like Juice came with inside a packaging that you can then make into a tuck box where you can store the kit. And so on. So it's always nice when that happens. So, but in this case, it's just fits.
Yeah, and it's nice to know that it's not going to go in the bin. The packaging.
Yes.
It's good. Less wasteful.
So no waste. Yeah, we don't want to waste.
So it comes with a sticker, and this sticker's functional as well as beautiful. The thing is we've designed it so that the light, this PCB goes inside the box, and it's a Lite2Sound device. I haven't explained what it is, have I?
Yeah, we didn't say. Yeah.
So let's have a look at the board first. This is one assembled, but without all the wires.
Focus.
Not focusing.
It's not focusing. Why is it not focusing when it needs to be focused?
There we go, ish.
Okay. Yeah, I think it's good as we're
gonna
gonna
down
get.
here. No.
Oh, here. This here.
Yeah.
Yeah.
It's better here.
Anyway. Oh, there we are. Yeah.
So
it converts changing light into sound.
Yeah. So it's using a diode, like in the reverse of an LED. Right. So it picks up light and turns that into a small current, which this circuit then amplifies and puts through speakers. Now, normally a LED, like a photodiode, you know, you can't hear you wouldn't be able to hear things moving very slowly.
Right.
It only really works at audible range.
Mm.
So, lights that oscillate between like 20, you know, the audible range, 20 hertz, 20 kilohertz.
Yes.
And yeah, so any sort of like static lights, like on lights that are just on,
Right.
or
But-
like really
but
high frequency lights, you won't be able to pick up. But
Yeah, but even light that is changing at higher frequency will have lower frequency components that would be audible.
yeah.
So I mean,
Mixing together.
you'll hear something
Yeah.
as long as the light is sort of changing.
The idea is it's basically it's not like a highly technical instrument. It's more like an experimental sound
Yeah,
explorer. So you
Yes.
can sort of walk around listening to different.
yeah. I mean, it's not a measurement tool.
No.
It's just to be able to, yeah, like you say, walk around outside and just listen to your
It's
environment.
fascinating how noisy some things are.
Yeah,
Imagining if like you're an alien and you listened with light, you'd be like,
Yeah.
oh, that
Yeah.
noise, oh my god.
Yeah. no, it is. I mean, we won't be able to walk outside here, but you did it. It was
Well,
like,
actually, if you go outside, it just goes silent because it's so bright.
okay.
You max out the.
You have to
the
get
diode.
close to the.
Yeah, because like if you imagine like a voltage,
But if you walk
sorry, yeah.
If you walk out at night when there's less light, and then you pick up.
Oh yeah, I've done that. The street lights, it's
Yeah,
crazy. It's
yeah.
like an orchestra of
Yeah.
frequencies. An interesting thing that happens is if you point to a window at sunlight, there's this very strange, windy sound.
Really?
I have no idea what it is.
Okay.
It's probably like something to do with the sun. No idea.
All right. So.
But basically, what it does is there's a circuit here that turns the small current out the diode to a voltage, like a wiggling voltage, removes the DC element to it, and then it goes into this, which is the amplifier.
Right.
That can amplify headphones, or you can plug it into a pair of speakers. And there's a little connector here where you can connect your own little mini speaker, so you can just have something
Yeah.
you walk around with.
And it's all nice. You try to keep it symmetrical, but it was a bit of a challenge circuit-wise, right? But it does have symmetry.
Yeah, it's got this sort of layout, sort of polar layout. The
Yeah.
origins around the
Well, we
eye.
can show the bare board.
Oh
right?
yeah,
And
that's
then-
easier.
Yeah. So there's this this eye. Yeah, there we are. There's this eye and sort of everything is on a sort of polar coordinate.
Yeah, I had it on a grid where it was all circles like this.
Yeah. Yeah, the image here is not doing it justice, really.
Yeah,
I think, yeah, it could be.
You
Oh, that's
switched
the
it.
other side.
yeah.
Yeah, it's nice and has a gold finish. It's a really lovely board, and this is the other side, right?
Yeah, I could show it at the same time.
Same time. Yeah, here we go. That's really it's really nice. I mean, yeah, we didn't know if we should broach the topic of this all-seeing eye, but here we might as well address it. It was kind of by fluke.
Yeah. What shall I go why that happened?
Yeah.
Here's the prototype. I was actually experimenting with putting a lens on it, which didn't work out in the end because just didn't get enough light coming through. I was making sort of a ground screen. And
So a camera obscura type of thing.
yeah,
or?
it still is sort of like a camera obscura, except for it's less elaborate as this.
Yeah.
It didn't work out because you could only pick up sounds from really bright lights, which are quite rare. You know, you'd only pick up sounds
exactly.
from like the office light, and that only goes so far before it gets quite boring.
That would sort of diminish the experience, wouldn't it?
Yeah. So, and it was interesting because you could target it using this ground. I was using masking screen tape as a ground screen.
Right.
And I was trying to you could sort of move it and see the light, choose what section of the light you wanted to do.
Wait, so what's the connection to the polar coordinates?
I don't know. Oh, the eye. We're talking about the eye.
Oh, the eye. Okay.
So I was imagining a cut out in the circuit board, which it still has.
Yeah.
Which you could actually still do with this if you wanted to experiment with it. You
Right.
could put it
Oh,
in
yeah, yeah. You can create a case of
put it in
your
a
own,
bigger
right?
box
Yeah.
and sort of try and play around with lenses.
Ah, that would be a nice project if somebody kind of 3D printed a holder for this.
That's why I kept it.
Yeah.
But rather than just doing a boring circle, I decided to make it an eye because I was
Yeah.
imagining this. See, the sensor is actually a tinted black resin.
Right.
Because it's actually meant to pick up infrared mainly,
Right.
but it picks up visible light too. So I thought
So
it'd be
it's
good as a pupil.
like a pupil. Yeah.
Yeah.
Yeah. And so, and the polar coordinates just came up as an interesting way to expand the eye.
Well, yeah, rather than sort of boring square of components, I thought it'd be nice to go
Yeah.
around the eye like that.
Yeah. Yeah, one of the things that, well, I mean, you could do any kind of angles on in any other software. I mean, but with PCB mode, it's kind of easy. But also, you don't see it that much. A lot of times, other angles than 45 degrees don't make much sense. But in this case, it's really neat. People are gonna mostly hand solder it. And well, even if you use solder paste or anything like that, it doesn't matter.
And also, if you're doing solder paste, the components will sort of automatically slip to the right angle.
Yeah.
Don't they?
No, I'm saying if it was a pick and place machine, that might some of them might have issues with the angle. Yeah. Maybe I don't know enough about the latest tech. Yeah. So okay, so this is we got the board.
Yep. So if you imagine the board's in there, the idea for the sticker that comes with it is that goes over and there's a cutout in it, so it does that sort of.
It restricts the light,
the
amount of light that goes in,
like an incredibly crude lens.
Yeah.
Just with a massive aperture.
Yeah.
That doesn't have any focal range, just
right.
like a big. But it does work. It's directional. It's directional.
Yeah, I mean the lens on the diode has what, 30 degrees? Is it?
Yeah,
or something?
that is a lens. Yeah.
So it's not.
It's kind of like an aperture in front of a lens rather than behind it.
It won't pick much from the sides anyway.
It probably restricts it because I think it is like something like.
Oh yeah, I mean
60
30 degrees is something. I don't know. It depends on the spec.
60, 30, whatever.
Okay, so we get and then the components, right? Yep. The PCB.
The components. There's a lot of components because it's an analog project.
Yeah,
it's really hard to keep the bomb down. You need a lot of. That's where Eric helped a hell of a lot. Trying to keep these.
So as it is, it's 19 different components.
Yeah,
it's the biggest.
It's the biggest different amount of components
in terms of. So just for context, the amount of bill of materials line items, which is normally what you want to minimize.
Yeah.
To us, it means that there's one more component that goes into the bag, needs to be counted, and so on. Yeah. So the fewer components, the better. The better it is for us. I mean, so if there is a possibility of reducing it, we do.
Yeah, it's a good point to mention actually that this project is actually based on two other projects that Eric did.
Yes, the
PX and the PD. I got it wrong. PX.
Yeah,
and
there's
PD.
two other ones, and that's why we call this one BC.
BC, yeah. Because those two are actually more like complex.
Yeah.
They have like automatic gain control in them.
So yeah, that's where we were getting at. The compromise was not compromise, but it is a compromise, right? So
this is like manual gain control. So when you pick up a sound, if everything's quite loud, you have to turn it down a bit. There's a high and a low gain sensitivity.
Yeah.
Yeah.
And so, but we had to strip down the automatic gain control.
Yeah.
we already had an on-off switch, so adding another one, that's not adding a line item, bill of materials line item, so that's okay.
Yeah.
And we had to add the potentiometer, right?
This affects the volume on the output, so it's more for like not hurting your ears.
Right.
This affects the sensitivity on the input. There's two settings, high and low.
I'm saying instead of the automatic gain control,
these are the
would
replacements.
have So
and there's a power switch as well, just extra.
So these are the adjustments, and like I said, Eric was very helpful in accommodating by modifying his circuit. So it worked out very well. All right, so and then the little surprise at the end.
No. You get the board.
You get the PCB.
Seen a lot of that already.
Yeah, lovely board.
And then there's a bonus.
What is that?
Which is shiny sticker. That's because it's left over from some issues with the stickers we found.
So I think, we had 3 issues that all were kind of minor, but together made us decide to redo with the actual with this one. So this is the second go. This is the first go, and what we found, the initial intention was to punch out the hole around the B, but we found
it's because the circle, that punching a hole wasn't in the capabilities of the sticker supplier.
Yes, so we wouldn't be able to use the sticker supplier, and anyway, we had punches from pips.
We've done loads of projects with holes in them.
Yeah, so it worked beautifully on a fairly thick card.
Yeah.
With pips, and so we thought, this is thin. It'll be obvious it's going to work. And then when we got it back, it was funny because I was making a video. and you received the stickers, and I was making the video, and at the end you go like, something's wrong. And because it's
what's got a metallized layer in it, isn't it?
It doesn't. The punch just doesn't go. Just doesn't create a clean hole, and it was just.
It was like a almost crisp packet or something, isn't it?
It was almost, but not quite, and we tried a bunch of different things to make it work, and it didn't work. No. So that was one thing. The other thing is we were. If you handle it too much, some of the black ink disappeared, and we didn't quite like that.
Yeah, it's got a white layer that.
Yeah, it's got a white layer, and then on top of that, so we worked this out with the supplier, but it was minor. And then the third thing was
it didn't.
Oh, it didn't stick very well.
No.
So it was okay, but it wasn't great.
Wasn't good enough.
For quality, so. We worked out with the supplier, and we've ended up with this one where we don't actually need to do. We said, okay, we'll have to reduce the amount of work that we do with this, and so we created this slot instead of having a punch. Now, punch it. Although this would be punched quite all right.
We don't want to risk it again.
Yeah, exactly. And so people can use this, right?
Yeah.
And
if you take a scalpel and carefully cut it, it's just we can't do that 600 times.
Yes, exactly. And also, I mean, it could be just a nice little sticker if you cut it just under the Boldport Club, and you have a nice sticker to stick on your laptop or forehead or whatever. Don't stick it on your forehead. On a laptop, it's better.
Yeah.
Stay there for longer.
Yeah.
Okay, I think we teased them enough. Since we should have note for next time, we should kind of show the result first and then go through, because
yes,
I think people go like, Show us what it's doing already.
Yeah. So here's a built one.
Right.
Oops. See inside. There's the.
We didn't talk about the hole.
Oh
so
yeah.
We punched holes through all of the cases, right? And then we're gonna have
There's a jack.
There's a jack.
It's the only access physically from the outside to inside to outside is the audio jack that you can listen with.
Right.
Makes it a neat device that you can sort of do this with.
So there's a jack and a nut that is coming with the.
Yes, it's part of the kit. Yeah.
Yeah.
The only thing that you need to supply is some wire.
Right, the wires aren't included. Yes.
Yeah.
But it's one of the things we assume people have.
We haven't included it in the past.
No. There's some things that, like a battery, right? You expect people to have batteries. You expect people to have wires. We've, I think the prototype we've done with rigid wires, that doesn't work very well. Yeah. So flexible wires works a lot better.
Or if you've got an old scrap bit of headphone wire or something, that might work well. Although you'd be careful with those because they're enamelled. They're quite tricky to use.
Okay.
But yeah. So I'm going to do a demo.
Yeah.
Here it is.
Oh, there's sorry. We supply feet, right?
Oh yeah.
So
it shorting out.
Yeah, so it's not going. It's not on the tin. So there's a big nice gap.
Yeah.
So you're going to get 3. I think 1 for under the battery.
The way it's designed, anyways, there's not a hell of a lot on the bottom, but there are the battery contacts.
Yeah.
And the.
It's as it is. It's floating, but
this decoration is not electrical at all.
Yeah. So, but the feet is going to hold it very nicely above the tin. Also, give it a little bit of friction.
Yeah.
Yeah. Okay.
Now this room is really noisy.
It is. Yeah. We have noisy lights.
So I'll plug it in. It's not on.
All right.
So if you hear that, that's the light.
Yeah.
It's these skylights.
Right. So you'll see it. You'll see. We're going to cover it so you get just
as well, so you can see it on that camera. And
so this is Pips.
We've got some Boldport projects that make cool sounds. Yeah, thanks. Interestingly, this one kind of goes. Let's turn it up. When you touch the button, it changes frequency.
Yeah, because the button is connected to the oscillator circuitry, so
it's quite cool.
So stop. Use the button to stop, and when you stop, it just stops. Yeah. So there's nothing moving anymore. Yeah. What else do we have? Oh,
this one's more subtle. This is
Monarch.
The Monarch. So if you do the antennas together, it goes.
Yeah, but the idea is it sort of pseudo-random pattern.
Yeah, it'd be like white noise generator, but it's quite low frequency.
It is a low frequency,
So it's like just about in audio range. Oh. Turn it up a bit.
That's pretty cool.
Yeah, it's got a bit of the lights in here mixed up with it.
Okay. Yeah, turn it out. Okay. Yeah, I wanted to show. I have this LED desk lamp.
Yeah. There's actually a much better video, demonstrating more diverse things you can do with it on Eric's.
Okay. No.
Yeah.
No. Okay. So before you do that, there's this. Yeah. Maybe turn it down a little bit.
All right.
Right. So put your hand.
Good.
So it's got low light. No, I just want to go through the lights. Yeah. So it's got the sort of lower intensity, higher intensity, and highest, and off. And this is pulse width modulated, so we would expect to hear that change. So let's see. So that's the lower intensity, higher intensity, and then on. We stop hearing it because it's fully on. There's no, the pulse width modulation isn't working anymore. So it's just the LED is fully on. So I'll do that again. See, off and on, fully on is the same. All right. That's not a very interesting thing, but as a demonstration goes, it's pretty.
It's hard to do it at desk because you kind of have to wander around with it with a pair of headphones. Sort of, it's quite fun to walk around if you're into that kind of thing. Walk around, listening to different sounds. Like you'd be surprised what makes noise.
Oh yeah, the phone.
Oh yeah, I can show you the iPhone 6.
You want to talk about the fact that the thing,
I accidentally matched
the
my
sticker
phone
matches. Oh, it's
yeah, it's scratched.
It scratches quite a bit.
I abused my phone quite badly.
Yeah.
It's got a infrared face identifier. This phone.
Every phone has that.
Not all of them.
It's let's just basically you have. Yeah, you have when you put your phone against your face, the phone needs to know to turn off the screen.
Yeah,
to save.
For,
yeah, so it's just detecting.
I don't know if they've changed that recently. Maybe they use cameras instead.
They could use the camera.
Because they're spying on you anyway, so they might as well detect it that way.
All right, but anyway, let's see.
So, phone off. It's really loud. This. Oh yeah. But it's got two frequencies. When it turns on, and then it slows down. I guess because it checks less often.
Oh well, that I'm doing this right. That's,
yeah, you could do a gig. Dubstep. Yeah. Just turn it off now.
Yeah. Okay, so I think that's that, right?
Yeah, sweet.
Oh,
yeah,
we are
pacing down at
the. Yeah, so
that's the
2 weeks from now. Sending. Yeah. If you want to get it, go to boldport.club and get it next month.
Make sure you got your wire ready. And your soldering equipment?
Yes, the wire, the battery.
Oh yeah, 9-volt battery.
Yeah, and earphones.
Yeah.
That's it. So let's say goodbye. It's been half an hour. That's pretty good.
Yeah.
For us. You're gonna do a video maybe. Oh yeah, the SMD components are 1206, which are
that's
quite large. They're a bit larger than 0805, so it's going to be a little bit easier to solder.
Yeah, I haven't actually talked about that. It's a bit it can seem a bit worrying if you've never done it before. Like it's going to be quite tricky.
Oh,
but actually,
surface mount.
Yeah,
yeah.
The surface mount, it's a challenge when you haven't done it before, but it's not actually that difficult. Much more difficult than through hole. You just had to make sure you don't sneeze or anything like that.
No, but even those 1206 is the thing.
Yeah, they're not pretty heavy.
So Ben's going to do another video of assembling the thing, right?
Yes. Yeah.
That's coming up.
Not going to use anything special. No fancy hot air or solder paste. It's just literally you can use an iron.
Yeah.
Just a normal iron. It will work fine.
We will do. Well, talk about it later. Doesn't matter now.
Yep.
The stencil and all that. I'm going to send out an email. All right. Thank you for watching, everyone. Bye.
Bye.